Hello class, today we're going to talk about section 3.3, which looks at rate of change and slope. By the end of today's lesson, you will be able to identify if a rate of change is constant, calculate slope, and find missing values from ordered pairs using the slope formula. Little vocab to start off with. The rate of change is a ratio describing the average amount of change from one quantity to another. So what this is saying is ratio means fraction. So we're looking at our dependent change compared to our independent change. If you remember what we talked about in chapter 1 when we talked about independent and dependent, when we're talking about graphing, our independent change is our x values and our dependent change is our y values. Which brings us down to slope. So that is one that we specifically use on a graph. The algebraic symbol for slope is m. That's why it says down here at the bottom, m is equal to. Not really sure why they picked m, but we're just going to roll with it. So, a couple different ways to help you remember slope is rise over run. How much you're going up and down compared to how much you are going over or horizontally. You could also think of it as change in y versus change in x. And this one on the end is going to be the most helpful for us. That's the algebraic formula, y2 minus y1 over x2 minus x1. Now those 1's and 2's are the little subscripts. We haven't seen those before. What that is saying is that when you have two xy pairs, we need a way to distinguish which one's the first point and which one's the second point. So what they do is they just add those little numbers as symbols to tell you that the x comes from the first point or the x comes from the second point. The y comes from the first point or the y comes from the second point. It doesn't actually have anything to do with numbers other than indicating which one comes first and which one comes second. There are 4 different kinds of slopes. These are the visual representations of them. First, you'll see the positive slope that's increasing up from left to right. Negative slope is decreasing from left to right. The horizontal line has a slope of 0. And the undefined slope is for a vertical line. So we'll get into what those look like algebraically in a minute, but this is what it'll look like if you put it on a graph. First thing we're going to talk about is that rate of change. So, the first type of problems we'll look at is asking you, are these rates of change constant? Easiest way to do that is to look at the dependent change versus the independent change. So we're seeing how much we are going up by from the dependent values first. So our results. So the first one we're going up by 15. Second one we went up by 22.50, and the last one we went up by 15. Checking on our independent changes, we went up by 2, up by 3, and up by 2 again. So now what we need to do to see if it's constant is to see if each of these ratios is the same. So our first ratio was a change of 15 to a change of 2. Which gives you a value of 7.5 when you divide that out. The second one was changed of 22.50 over 3, which again is 7.5. And the last one was a change of 15 over 2 again, which we already have said is 7.5. So since all 3 of these ratios turn out to be the same, we have what we have a constant rate of change, or for those of you at home that like abbreviations, CROC, constant rate of change. Go ahead and decide if this one is a constant rate of change. Looking at our values, we're changing by a constant rate on the independent ones, always going up by 2, but on our dependent values, we're changing by either 2 or 4. So those ratios do not work out to be the same, so this is not CROC. If you have questions about that, please let me know when you get to class. Next task we have is to find slope. If you remember back from that vocab slide, our slope equation was m is equal to y2 minus y1 over x2 minus x1. Given our points, I find the first thing helpful to do is to label out what you have. So that -3 is your first x, 0 is your first y, 2 is your second x, and 3 is your second y. So plugging that into our formula, we're going to say 3 minus 0 over 2 minus -3. Notice that first x value is negative, so we still have the minus from the equation and the negative from the 3. Minus a negative turns into a positive. So for our final answer, we end up with a slope of 3 minus 0 is 3, and 2 plus 3 is 5. So we have a slope of 3/5. So what that would mean on the graph is you would go up 3 and to the right 5. Go ahead and try this one on your own. You should have gotten a final answer of -1/2. It doesn't matter if the negative is on the top or the bottom or in the middle like I have it. Wherever you put it, that's fine as long as there is only one negative. You also should be reducing from the 5/10 to 1/2. You should always reduce your slope as much as possible. Two other things that we need to talk about with slope. So this first one, we've got x1, y1, x2, and y2. When we are plugging those into the formula, I get -1 minus a -1 over 2 minus -3. Those minus negatives turns into pluses, and I end up with 0 over 5. Reducing that. If I have 0 things and I'm splitting them among 5 people, we end up with 0. So this would be the slope of 0, or that horizontal case from the pictures of the graphs that I showed you. The other one that we have over here, again, x1, y1, x2, y2. When I plug that in, I end up with an answer of 2 minus -4 over 5 minus 5. Minus negative turns into a positive, and I end up with 6 over 0. When you would plug that into your calculator and do 6 divided by 0, you're going to get what we call a divide by 0 error. That is because, as you learned when you were learning about multiplication and division, you can't divide by 0. So this is what we call an undefined slope. Yes, you have to write out either 0 or undefined if you have a 0 as part of your answer. I will not accept 0 over 5 or 6 over 0 as part of the answer. That would not be okay. So you either need to indicate that it's equal to 0 if the numerator is equal to 0, or undefined if the denominator is equal to 0. If you have questions about that, please let me know when you get to class. Last thing we need to talk about is finding missing values from an ordered pair. So the slope of a line is 5/3 and passes through the point -2, 0, and 1, n. So we're missing that second y value if we go through and label our points. We can use our slope formula to help us out. So we know the answer to slope now, so instead of writing m, I'm going to start with saying 5/3. Then we still have our difference of our y's, so y2 minus y1 over x2 minus x1. Simplifying to make that positive. Next thing you're going to want to do is simplify if you can. I'm leaving the -0 there for just a minute. We technically could get rid of that, but I'm going to show you what that would mean if there was a different value here. So, in order to solve a problem like this, you would be cross-multiplying. So I would get 5 times 3, which is 15, is equal to, in parentheses, and minus 0. Again, since it's -0, it really doesn't matter, and we could just say 3n. But for other problems in your homework, you are going to need to use those parentheses and be able to do the distributive property in order to solve the problem. Finishing this out, divide both sides by 3, and n is equal to 5. So that would mean this ordered pair up here is 1, 5. If you wanted to, you can always go back and double check that with your points now and say y2, which is 5, minus y1, which is 0, over x2 minus x1, which checks out to 5/3. So you can always plug your answers back in to check that you are correct. Go ahead and try this one on your own. You should have gotten a value of n is equal to 17. If you have questions about this or any other part of the lesson when you get to class, please let me know.